All right, so last couple of days we've been talking about chemical reactions, okay? And on Monday, we're going to be in the lab doing another lab, but this time we'll be making chemical reactions happen. Okay, so it won't be about just looking at the individual stuff. This time we'll be putting stuff together, looking at the signs of a chemical change, okay? Kind of predicting what the products will be. We'll be getting to that here as well. Okay, but for the next little bit, okay, we're going to need to practice our reaction skills. That is, being able to identify the reaction types, being able to balance them consistently. Okay, getting the names or the formulas and all of that stuff correct. Okay, and yesterday we were talking about the two different ways that that reactions can go. Okay, and the first way that we went over was if I give you the actual formula reaction, okay, or the reaction in formula form, ask you to write it out in words, identify the type, and balance. Okay, and that was kind of the first way. We said that was a little bit easier because you didn't have the pressure of getting the formulas right and then possibly not having the balancing go right. Okay, and the other way was if I gave you the word equation, okay, and you had to go back the other way. You had to come up with the formulas, get them right, then get the balancing, and identify the type. Okay, so what we're going to be looking at today is just a bit of practice on those things, just to kind of get the hang of how this works. And about halfway through the class, I'll give you a bit of a break. We'll talk a bit more about the lab that we're going to do on Monday, okay, so you can start getting your head around that, and then we'll get back to this stuff here. So for these first few, these are in your digital workbook. Okay. They're in your digital workbook, and it is on page 8 of the digital workbook. So that's where you're working out of today. Okay. So same reactions there. And I'm going to post the key in Google Classroom here right away once you get started so that you can check them as you go. All right. I would do one reaction, check it. Do another reaction, check it. Don't do like 5 or 6 and then check. You have too much to check. Okay. So as soon as you do one, check the key afterwards. All right, so let's just have a look at kind of the first one here. I've got it done on my sheet here. So our first thing is we were given iron is reacting with hydrogen chloride. Okay, that's going to form iron 2 chloride. Okay, and how do I figure out it was iron 2? Okay, as I always do, I look at the non-metal. Okay, the non-metal is chlorine, which always has a -1 charge. Okay, and okay, as a result, okay, if there's 2 of them, then I know that this single iron has to have a charge of +2. Okay, and so iron 2 chloride, and then obviously this is just hydrogen, okay, written as an element. If I'm balancing that, I would start out with the chlorine first. There's 2 on this side, so I put a 2 in front of the hydrogen chloride, and when I do that, that gives me the 2 hydrogens over here, okay, and makes the whole equation work. All right, what kind of reaction were we looking at there? Single replacement. We got element reacting with compound, okay, to form a new element and a new compound. Okay. All right, so I would like you guys, let's say, to do from 2 to, let's say, I think yours goes up to 10, right? 2 to 10. Okay. And then we'll go through a few of those because there'll be a couple in there that'll give you trouble. There's a couple of tricky balancing ones in there, like number 8 is a bit of a tricky balance. And yeah, I think it's just number 8 that's the tricky balance, but okay. We'll give those a try. Number 8 is also tricky in that it doesn't look like any of the ones we went over. Okay, but its form is generally like which reaction? Yeah, it is actually a synthesis reaction, right? Anytime you only get one product, it's a synthesis reaction. In rare cases, you can have a compound reacting with an element to form a single compound. It's still a synthesis reaction. Okay, so that one's a bit tricky. All right, I'll give you a little bit of time. Let's say just go up to number 8. Okay, go to number 8, and then we'll go over them here on the board. Okay, if you're having trouble or you have questions, please ask. Okay, I'll circulate around and try and help out as much as I can. All right, so our second one here, we've got sodium reacting with chlorine to produce sodium chloride. All right, what kind of reaction are we looking at? The synthesis reaction, right? Okay, and for balancing, what should I start with? start with my biggest number, chlorine. Okay, there's 2 on the reactant side, so now there's 2 on the product side, but when I put that 2 there, it also applies to the sodium. So I've got to go back over to the reactants and make sure that I have 2 sodiums on the reactant side, and now the reaction is balanced. Okay. If you got questions as we're doing this, guys, don't be afraid to ask, okay? Okay, for number 3, we've actually seen this reaction before. We have water, okay, and it is breaking down into hydrogen and oxygen. Okay, what kind of reaction are we looking at? Decomposition reaction, yeah. Okay, now for balancing, my biggest number is at 2, but I got 3 things that are at 2. Okay, got hydrogen that's a 2, got oxygen that's a 2, but the hydrogen's already balanced as a 2, so I got to go with the highest number that's not balanced, that's oxygen. Okay, so if I got 2 oxygens over here, what do I need to put in front of water on the reactant side? Okay, how many hydrogens does that give me? 4, so I need to make sure I have 4 hydrogens on the other side. Okay. And for number 4, we've got calcium reacting with oxygen, and that's going to form what? Calcium oxide, right? Ionic compound. We don't need any prefixes or anything like that. Okay, got a balance. Biggest number is 2 on the oxygen. Okay, so I'm going to put a 2 here to balance my oxygens, but when I put the 2 there, it gives me 2 calcium, so I got to go back over to the reactants and put a 2 in front of the calcium. Okay, so the synthesis reactions all kind of work the same. Okay, I think we've had now a couple like that. It's not always going to be a 2, but okay, it's going to work essentially like that. Okay, for number 5, Al is aluminum. Okay, it's reacting with oxygen, and that is going to form, what do we call this stuff? Aluminum oxide, right. Do we need any Roman numerals or anything like that? Does aluminum have more than one possible charge? No, so we don't need any Roman numerals in that name. Okay, so to start my balancing here, I've got 3 oxygens on this side, it's my biggest number, and I've got 2 over here. Okay, so what's my lowest number that they'll both go into so I can make this equal? 6. Okay, so I'm going to put a 2 in front of here to give me my 6, a 3 in front of this one to give me 6. How many aluminum does that give me? 2 times 2 is 4. Okay, so I need a 4 in front of that. Okay, making sense so far? Hannah, making sense? Okay. Number 6, okay, we got bromine, okay, reacting with sodium chloride. And that's going to make sodium bromide. And chlorine. Okay, what kind of reaction are we looking at there? Single replacement, okay? In this case, the element is a non-metal, okay? But it's still a single replacement reaction. What should I balance first? Chlorine or bromine, doesn't matter. Either one will work. They're both 2s, okay? I'll start with bromine just because it's first in the reaction. There's 2 bromines over here, but there's only 1 over here in the products, so I need 2 of these. But when I put a 2 there, it gives me 2 sodiums. So I've got to go back to the reactants and make sure I've got 2 sodiums. When I put the 2 there, it gives me 2 chlorines, and there's 2 chlorines in the products, so I'm good. Got it balanced. Okay, how many people are done up to number 8? That's kind of what I thought it would look like. Okay, for number 7, I've got copper. Does copper need a Roman numeral? Only when it's in a compound. Okay? It doesn't have a charge as an element, so I don't put a Roman numeral on it right now. I will put a Roman numeral on it on the other side, but that is a very common mistake that I see, is people over-applying. Like, oh, copper is multivalent, I need to put a Roman numeral on it. You do, if it's in a compound, but when it's as an element, it doesn't have a charge. Okay? so we don't put the Roman numeral on there. Okay, copper plus sodium chloride is going to give copper chloride, but we got to figure out which copper it is. Okay, so chlorine's a -1 and there's 2 of them, so that means this is the copper with the 2+ charge, so put a Roman numeral 2 in there. Okay, copper 2 chloride plus sodium. Okay. On a unit exam, on the assignment on reactions, that's one of the kinds of places where people lose marks. They either put the Roman numeral over here and lose a mark, or they forget it over here and lose a mark. Okay? So just make sure you're knowing the Roman numerals are used in compounds only, on multivalent metals only. Okay, to balance this one, the only thing that's out of balance right now is chlorine. There's 2 on the product side, so I'm going to need to put 2 on the reactant side. Okay, that'll give me 2 sodiums, so I need to go back over to the products and make sure I have 2 sodiums, and that will make everything work in that reaction. Okay, number 8. We already talked about it. It is a synthesis reaction because it only has 1 product. Okay. The stuff that's in it is a bit tricky for naming. Okay, SO2 is a molecular compound, sulfur dioxide. Okay, it's reacting with oxygen. Now, a lot of people look at SO3 and they go straight to their table of polyatomic ions and say this is sulfite, but it's not. Okay, sulfite as an ion can only be present in a compound. It will not exist by itself. So this is a compound and must be named as such. This is sulfur trioxide. Okay, so it's one of those little things about reactions we need to know. You'll never have a polyatomic ion by itself. Okay, it'll always be in a compound. If something looks like it's a polyatomic ion, name it like it's a compound. Okay, now I've got to balance. Now, I've got lots of numbers here. Oxygen is my highest number. Okay, it's a 3. I've got 3 oxygens on the product side. How many do I have on the reactant side? 4. Okay. Common multiple of 3 and 4? 12. Okay. So I'm going to start out with that. I'm actually going to have to reduce it after, but I'm going to start out with that because that's the kind of general way to do this. So on this side, I want to make sure I have 12 oxygens. So I'm going to put a 4 here. Okay. When I do that, it gives me 4 sulfur. So I've got to go back over to the reactants and make sure that I have 4 sulfur. Okay. Now, on this side I have 8 plus 2 is 10 oxygens, and I'm supposed to have 12. So what do I need to put in front of this? A 2. Okay, now this happens sometimes. 4, 2, 4. Can I reduce that? Yes. If that happens, you must reduce to lowest terms. Okay, so this can actually reduce down to 2, 1, 2. Okay, and it'll still be balanced. Okay, I've got 2 sulfurs, 2 sulfurs. 6 oxygens. 2 times 2 is 4, plus 2 is 6 oxygens. It still works. Okay. All right. Take a little break. I'm going to give you about 4 or 5 minute break here. Okay. Then we're going to go back to the other type of question where you get the word equation and have to put it in formula form. Okay, so about a 5 minute break here. If you need to use the bathroom, something like that. All right, so for these 4, okay, we're given the word equation. We need to go to the formula form of it, identify the type, and balance. So for our first one, we have magnesium, just an element, okay, not with anything. Reacts with chlorine. Okay, what do I need to remember about chlorine? It comes as a 2, right? It's special. Okay, that's going to form magnesium chloride. All right, that's an ionic compound. This is a 2+, that's a 1-. So when I drop and swap, I'm going to end up with this, which is great because what does it do to my equation? It makes it balanced without me having to put in any other numbers. Okay, it's already balanced the way it is. What kind of reaction is it? It's a synthesis reaction. Okay, so those are, you know, like that's a fairly straightforward one, but here's where we're headed to. Next week, I give you just the reactants. You have to predict the products. Now, would you have been able to predict that those two things would go together in a synthesis reaction to make magnesium chloride? I don't know what else it would have done. I mean, realistically, really, what else, right? Like if I put those two things together, I'm going to get one thing. It's a synthesis reaction, and what happens in a synthesis reaction is two things go together, right? We don't have any other reaction types that start with two elements, okay? So all it becomes a matter of is being able to identify the type and know what will happen, and then make it happen, okay? All right, for this one, I have dihydrogen. I think I fixed it on yours, though, hydrogen. Okay, oxide, which is actually water, right? This stuff. And it gives off hydrogen and oxygen. So gives off means it didn't react with anything. It just broke down into these two things. What do I need to remember about those two things? They're both special. They both come as twos because they're on my list. Okay, they're in the top right corner of my periodic table. All right, what kind of reaction is that? Yeah, separation, decomposition. Okay, now I need to balance this thing. Hydrogen's already balanced. Okay, we got to go back here and balance the oxygens with a 2. When I do that, I need a 2 here for my hydrogens. Okay, I think we've seen that one like 5 times now. Okay, that same reaction. Okay, aluminum reacts. Aluminum and oxygen produces aluminum oxide. All right, so aluminum is this. Oxygen is, okay. So even if I didn't know this is what was going to be produced, what kind of reaction am I looking at? Synthesis, the only kind that starts with 2 elements. Okay, so I'm going to put them together, Al and O. This is a -2 and this is a +3. So when I drop and swap, Al2O3. Okay, so really predicting the products is not all that hard. We just have to know what happens in each of the reaction types to do it. Okay, so now I've got to balance this, and I think we've seen this one before as well. Okay, I've got 3 oxygens on that side, 2 over here. Lowest common multiple is 6, so I'm going to put a 3 in front of this and a 2 in front of this. But when I do that, it gives me 4 aluminums. So, 4 in front of that.
On your key in the...
Oh, yes, there's a mistake on my key. It says ALO, doesn't it? I keep thinking I fixed that, and I still haven't fixed it. That's what it should look like. Key's wrong. Yeah. All right. Phosphorus and oxygen. Okay, so phosphorus and oxygen. Now, we already have done oxygen a bunch of times. It's special, but not as special as phosphorus, which comes as a 4. Okay. Again, another what kind of reaction? Synthesis reaction. Okay, so these things are going to go together to make phosphorus pentaoxide. Does yours say tetraphosphorus on yours? It says phosphorus. Sorry, pentaoxide. Why am I putting a 10 there? I only need a what? 5. Okay. So, what should I balance first? Yeah, I would say probably oxygen's my best bet, but the problem is, if I put a 2 in front of the P to make 10 on each side, I'm going to have to change it, aren't I? Okay, so this is one of those cases where I picked the highest number, but I should go with something else first. Okay, because I can already see that that's going to produce a problem. If I put a 2 here, okay, I'm going to have to go back and change it because I got more than that on this side. All right, so I don't want to do that. I want to balance the phosphorus first. Okay, so now my phosphorus are balanced, but now I have how many oxygen? 20. Now I have 20 on the reactant side. All right, how are we feeling about this stuff? Starting to make a bit of sense? It's pretty, like, mechanical. Okay, you kind of just do the same steps every time. All right, I want you to try the rest of those. Goes up to 9, right? Okay, so just try the rest of those. Same idea. Reaction types balanced and in formula form. Okay, so if we're looking at number 5, we got nitrogen trihydride. That's this stuff. Okay? It's reacting with oxygen, that's this stuff. Okay? It's producing nitrogen and water. Okay? It's essentially a type of replacement reaction, except that ammonia is actually a molecular compound. Okay, so it's not a true single replacement reaction, okay, but it's a type of replacement reaction. Obviously on a test, okay, or something like that, I wouldn't give you one that doesn't fit our patterns exactly. Okay, this one doesn't fit our patterns exactly. It isn't a true single replacement reaction, but it is a type of replacement reaction. Okay, all right, so I've got my formulas written out, okay, and now I need to balance this thing. It's going to be a little bit tricky, okay. What should I look at maybe balancing first? Yeah, look at hydrogen first, okay? It's probably a decent bet. If I put a 2 here, okay, that'll give me 6 hydrogens. It'll also balance my nitrogens, which is nice, okay? But it's going to produce a problem. The oxygens don't work with that number, okay? Because if I come back here, I have to put 1.5 here, and that doesn't really work. But how do I get rid of a 1/2? Double it. Okay, so if I double the numbers I put in here, and start with a 4 instead, it might work. Okay, so now I have 12 hydrogens, so I'm going to put a 6 here. Okay, that'll get me a nice even number of oxygens. I can go with a 3 here and a 2 here. And that does work, and I can't reduce it any further because 3 doesn't reduce down. Okay? That's a tricky one for balancing because it doesn't work the first time through. Okay? And that does happen sometimes. First time through it doesn't work. Okay? If you ever run into that problem, and it usually happens with oxygen, okay, where you have to have like 1.5 or 2.5 or something like that, double the first number you used. That's why we have the rule of 2 in combustion reactions, because it always happens in a combustion reaction with an even number of carbons. All right, how many people are done number 6? Okay, let's have a look at that one. So we have carbon and oxygen producing carbon dioxide. So carbon is just an element, okay? Oxygen wow, they don't get much easier than that. Okay, it's already balanced, and it's what kind of reaction? Synthesis. Okay, keep going. Give you a few more minutes and we'll go through the others here. Okay, so for number 7 here, we got calcium oxide. Okay, so that's Ca, 2+, oxygen, 2-, so CaO is good for that one. And magnesium chloride. So magnesium, which is a 2+, with chlorine, which is a 1-, so MgCl2. Okay, so that's going to be, what kind of reaction is that before I even write the rest? Double replacements, 2 ionic compounds reacting. Okay, here's another one where example of predicting the reaction. Okay, in a double replacement reaction, what do the metals do? They just switch places. Would I be able to very easily figure out what goes on the product side without being told? All I do is switch the metals. Okay, so I would have on this side then calcium with chlorine. That's a 2+, and that's a 1-, so we'll have CaCl2. Okay, and magnesium, which is a 2+, with oxygen, which is a 2-, so MgO. All right, so there would be my double replacement reaction, okay, written out with all the formulas correct. Now I need to balance this thing. Good. Already balanced, right? Chlorine's a 2 on both sides, everything else is a 1. Okay, so it's already balanced. Questions on 7? All right, we got hydrogen iodide. That's an ionic compound. Hydrogen's a 1+, iodine is a 1-, so it's just high. Okay, and oxygen produces iodine and water. What do I need to remember about iodine? It's special, comes as a 2, okay, and water. Okay, what should I balance first? Lots of things are 2s. Hydrogen already works. Okay, I could balance the iodine, and that would no, it wouldn't do it. Okay, I should probably go with the oxygen first. Okay, how did I decide that? It's the biggest one, but also when I looked at iodine, I knew if I came over here and put a 2 in front of this, it wasn't going to work for my oxygens. Agreed? Okay, so I'm gonna do oxygen first and make sure that oxygen is balanced. By putting that 2 there though, it gives me 4 hydrogens. So I've got to go back over here and put a 4 in front of the hydrogen iodide. Doing so gives me how many iodine? 4. Alright, now I've got 4 on the product side as well. Okay, and our last one, we have magnesium and nitrogen. So, magnesium and nitrogen. What do I need to remember about nitrogen? 2. Okay, so Mg is a 2 plus, N is a 3 minus. It's an ionic compound. When I swap and drop, I should end up with that as magnesium nitride. And now I have to balance this. Looks like my nitrogens are already balanced, so all I have to do is put what in front of the magnesium? 3. All right. Questions on any of those? Okay. So next week, okay, and we'll probably start this on Friday, okay, but we're going to have our lab on Monday, right? I want to do the pre-lab activities on Friday. So we'll have the Chromebooks for probably half the class or so, and we'll get going on the hypothesis, variables, all that kind of stuff, so that stuff is all done for you, okay? And then on Monday, straight to the lab, okay, putting things together. Okay, there's not nearly as much to do in this lab. You just have a few combinations that you have to observe after you combine them, and then we come back and we'll look at predicting the reactions and all of that kind of stuff, because that's what will be coming up next. Okay, so tomorrow you'll have a quiz. Okay, there'll be questions like this. So there'll be some figuring out of, going from formulas to word equations and word equations to formula equations, balancing and identifying. So expect that for tomorrow's quiz, which I'll post at the end of the day. Okay. Lab stuff Friday, lab Monday. Okay, and then guys, I will probably give you your Unit 1 exam date next week. Probably Monday or Tuesday, I'll give you the exam date. Okay, that'll give you 10 days to 2 weeks notice, okay, of when that will happen. In fact, I may figure it out even earlier than that. But, okay, expect that it is probably around 2 weeks away at this point. Okay, so if there's stuff you're still struggling with, make sure you're coming in to see me, get some help, okay, stuff like that.